And Ryan, go ahead. Floor is yours.
Okay, thanks, Naveed. So, hi everyone, Ryan Murphy. We're going to spend the next 28 minutes talking about Azure Stream Analytics. And so I'm going to jump right in. First of all, just a little background on me. I'm a cloud solution architect at Microsoft for about the past 2 years. And prior to that, did data management, integration, architecture, various things with data for quite a few years, including 10 years in the casino gaming industry and a few other industries too. And I think especially relevant to this talk, and because I needed to get a plug in, recently co-authored and contributed to a book on Azure Stream Analytics. And so, if by the end of our session here, if you want way more on Stream Analytics, then I encourage you to check it out. Okay, so our agenda is going to basically be, I'm going to go through from high level to some basic capabilities of Azure Stream Analytics, followed by a few of the more advanced analytical capabilities, and then a demo. And I'm going to do my best to save a couple minutes for 1 or 2 questions at the end. I'll do my very best to do that. Okay, so just to start out with, what do we mean by streaming analytics? Streaming analytics sort of refers to doing analytics on data that is in motion or that is still in motion. And you can contrast that to the traditional paradigm of analytics on static data, or the traditional mode of loading data into a database, usually at like regular intervals, say once a night. And so each night you might load append the past days of data, worth of data, into your database. The next day you'd append another day, and then separately you'd have analysts doing queries and doing analytics on your database. That's been the norm, that is still generally the norm, and that's been a great way to do analytics. However, if you can get to the analytics the streaming data while it's still in motion, that'll actually give you some opportunities to do different things that just weren't possible if you waited around to analyze data that's already been stored in a database. A couple of examples are fraud detection. So you could do fraud detection against a database, no problem. But if you can get to a transaction that is fraudulent almost immediately within milliseconds, well, now you may have an opportunity to do something more preventative or some more meaningful remediation. Another example is a overheating engine. If you can catch and detect an engine that is overheating within a couple of seconds, you may be able to actually react to that and do something about it, prevent something more catastrophic and damages that could result from that, and of course associated costs. So that's sort of what streaming analytics as a concept is. It applies to, we talked about a couple of cases, but it applies to all kinds of industries and all kinds of different scenarios. Many of them are Internet of Things types of scenarios where you have events that are being sensed on devices and emitted, sent out. That's a common scenario. But actually, streaming analytics can be done on even when you're not in the context of physical devices. Really anything that is generating or creating data and events, including things like a web application or any kind of IT system that does logging. Those are good examples. These are all use cases for stream analytics, which is why we've got quite a few customers using the Azure Stream Analytics tool. Thousands of them. You'll recognize a lot of these organizations. So on with specifically the Azure Stream Analytics service. So there are a whole host of services in the market technologies in the market that you could, and open source ones you can combine and use to enable streaming data pipelines and analytics on those pipelines. You can certainly do that. And actually, we're happy if you do that in Azure. The Azure Stream Analytics service itself offers some unique benefits, though. And so I just want to cover a few of those. One of the, maybe the most popular one is programmer productivity, and that's because Stream Analytics uses an SQL-like query language, and developers are basically most developers know SQL. Developers who work with data are typically familiar, or at least somewhat familiar, with the SQL query language. So onboarding to the Stream Analytics service is there's a very low barrier to entry. If you know SQL, then you can develop Stream Analytics jobs. So it's very easy to start being productive on the tool. It's easy to get started too. And one of the reasons is all the integrations that are built in between the Azure Stream Analytics service and other like storage services, so connectors within Azure. Also, it's a serverless PaaS service on Azure, so it has a lot of the other typical things that you'd find in a PaaS service on Azure. There's no provisioning of infrastructure or management or maintenance of infrastructure. There's a pay-as-you-go model, so you're paying for what you use and paying as you go, and then you get an enterprise-grade SLA too. Okay, I just want to kind of hammer home the point about the SQL, because this is such a powerful point. We say it's a SQL-like query language, but anyone familiar with SQL will sort of recognize here, and I'm not going to look through every construct here, but you'll recognize all the main ones: select, from, where, group by, joins, unions, the typical aggregate functions like sum and count and average, min, max. And there are also temporal semantics that have been that the SQL-like language has been augmented with. So for windowing, this is a fundamental concept to analyzing streaming data. This is sort of the probably the biggest difference with analyzing streaming data versus static data, where you need to break up your stream into defined windows of time, and then you would be running queries or analysis functions, aggregations over those defined windows of time. So there's some semantics that have been added to the language that enables you to do that. Okay, so here's a basic kind of a canonical architecture for Stream Analytics. So these are the typical things that we find it doing, so where it fits. From the left, you have the what are producing or generating events. Oftentimes, those are devices or sensors that are emitting events. I think, like I mentioned earlier, sometimes they're not a physical device, but it could be an application. And those are ingested into some type of a hub, oftentimes an Azure Event Hub or IoT Hub. And reference data can also be used as an input. So we find that in blob storage. So Stream Analytics will grab, knows how to take those as inputs, the streaming data and the reference data, and then it can call out to an Azure Machine Learning service to add on a machine learning score or prediction, and include that in the output. And then a few different typical types of output that we see are, from the top, long-term storage. Inexpensive long-term storage usually is part of a Stream Analytics job. So that might be blob storage or data lake storage or some database. And then in the middle would be the very recent or recent trends or events that you might want to visualize. So those often will go to a visualization tool like a Power BI. And then finally, the third sort of typical type or category of outputs for Stream Analytics have to do with downstream workflows. So a good example of this is a Stream Analytics job could detect when a temperature went above or below a certain threshold that it's expecting. And when it does, grab that event immediately and send it downstream to some Azure function or put it on a queue that will trigger a downstream workflow, like updating or notifying a service technician or doing some sort of field service update or notification. So these are the typical kinds of inputs and outputs for Stream Analytics. Okay, this one's quite straightforward. It's basically the thing that you're deploying and working with is a Stream Analytics job. This is quite straightforward. You essentially have, and we're going to see this in action, you essentially just have your inputs, one or more inputs, the query that's doing something with those, and one or more outputs. It's pretty straightforward. Yet, there are some pretty interesting things you can do with that query. And I just want to call out a couple of examples, because these are some of the things that aren't necessarily immediately obvious to someone who's just getting started in the service, or particularly just getting started with working with streaming data. So you can use this SQL language to detect the first or last event in a window of time, or detect things like the duration between two events, or the duration between a condition being, say, true or false. You can do things like detect the absence of an event that you might be expecting, or filling in missing values that you were expecting, or that you want to see. So there's some interesting things you can do using this tool. Okay, I'll touch on a few of the more advanced capabilities. I'm not going to dive all the way deep into every one of these, because I want to kind of get onto a demo in a couple minutes. But I do want to highlight a few of them. One is geospatial functions. So there are actually native geospatial functions built into the service now, and I've got a couple examples here. As you can see, you can do things like calculate the distance between two locations. This might be particularly helpful if as in this example, if the source of your events is itself moving. Car or vehicle, you have the source is moving around. You might want to know from moment to moment where it is in relation to something else. This can be very helpful. Like in the example here, where is your car versus how close are you to say a gas station? And then overlapping geographic territories or polygons is one of the other examples of something you can use these geospatial functions to calculate. And there are a couple of things we can do with machine learning. One, I think I mentioned in the architecture slide, is the integration with Azure Machine Learning Studio and Stream Analytics. So if you had built a machine learning model in Azure Machine Learning Studio and converted that or created a web service out of that, which is something you can do in a few clicks in that tool, then you can integrate that model, that web service right here in your Stream Analytics job. So you just create a function, you give it pass that API in, and once you do that, then you can use it in your SQL query, just like any other function. So in the example we have here, there's a sentiment model that was created, and you can just pass it the text, get back a sentiment score based on that model that you had built, and then you'd be pushing again, this is in the stream, so when you'd be getting the sentiment in real time and outputting that into wherever you're going to push and store this data. It'll have with it the original text as well as the sentiment. So that's pretty powerful. One other slightly newer and related feature is one particular machine learning model based on that is for anomaly detection. And the difference with this one is that this is anomaly detection is an algorithm that is now built into Stream Analytics. So this is not one that you have to go build yourself and then integrate it in here. This one you just get it it comes with the tool now. It comes with Stream Analytics. This is a built-in function. And the way you use it, and all you have to do to use it, is just like what we see here in the query sample. You just give it a window of, I'm not sure how easy it is to read the picture, but I hope you kind of get the idea. You give it a window of time that will establish your normal baseline of activity, and then the anomaly detection function will will detect when something out of range occurs and set off emit a anomaly score. It'll raise an anomaly score, and then on its own, based on the amount of time that you gave it to look back to establish a baseline of normal activity, it'll on its own establish a quote unquote new normal, and then only when an event is detected which diverges widely from that will the next anomaly be raised. So that's also very interesting that it comes right in with the tool now. Okay, and the only other one I wanted to show you right off the bat is deploying Stream Analytics to IoT Edge. Now I know that in this Azure Power Lunch series that there was a deep dive on IoT Edge recently. So I'm not going to go into what IoT Edge is totally, but I just wanted to use this as a kind of reminder that Stream Analytics can be a core and strategic kind of component as a part of IoT Edge, and about how this is a different way of deploying and working with streaming data. In this case, you build your Stream Analytics jobs just like we kind of already sort of reviewed in Azure, and then you can use via the IoT Hub to turn your Azure Stream Analytics job into a Docker container and push it down to the IoT Edge device, and it will at that point it runs on the IoT Edge, which is to say on premises or on site. You'll have your Stream Analytics job, whatever logic you coded into your query will be running on the device, so it will not be running in the cloud at that point. And even if you lose connectivity with the cloud, it will continue to run as you configured it on the Edge device. So that's a pretty interesting new deployment model. Okay, so let me show you an example here. Okay, so I'm just going to go over to the Azure portal and just take a look at what it takes first of all to create a Stream Analytics job. So I'm in the Azure portal. Let's hit the Create Resource. I'll just do a search. Grab Stream Analytics job. There it is. Hit Create. This is pretty straightforward, so I'll just give it a name. Maybe I'll come up with some new resource group to throw it in. Here's the Edge versus Cloud deployment option. I'll leave it in the cloud for now. And just to the dashboard and create. So that is literally all it takes to get a job created. And this will take. I'm actually going to open one that's already running, but you'll see how fast this is. In fact, it's already finished. So that literally in like seconds, the Stream Analytics job is deployed. So actually, why don't I just take this minute to take a look at this is a fresh one. So here you would configure your inputs, your outputs, and then write your query. As you can see, it is just simple, straightforward select statement. It could be simple. It could be more complex. If you wanted to create an input, you can click on here, say, add a streaming input. I think I have an IoT Hub already provisioned. So I think it found that. So I could say yes, make that my input. And likewise with an output, I might say these are the natively integrated outputs. You could choose any of these. Maybe I would put it in an existing blob storage account that I have. And then write my query to actually put data from the IoT Hub into that blob storage account. That's sort of like dead simple. That's how easy it is to get started. But to give you a look at one that's a bit more interesting, it's already running. Here's a case of one that is vehicle telemetry data. This is a sample of vehicle telemetry data. And you can see there are multiple inputs, multiple outputs. The inputs are, there's stream in data from Event Hub. The blob input is actually reference data. So if you can imagine events coming from a vehicle, that would report things like the speed, the engine temperature. And then in the reference data, I've got a sample I would show you just to make it a little clearer. Here is just a view of here's the reference data. This is a CSV. It simply has the VIN, vehicle identification number, and the model name. The reason this is helpful is because in the telemetry coming from the vehicle does not include the model name. It just has a bunch of IDs and numbers. So in order to make sense of it, we have this reference data stored separately in blob storage, and then you can join this with your stream right here in the job. And then in the output include the model name with your events. So I want to show you where that's being done here. Just expand this. Here we can actually see, here's the 3 different outputs that are happening at the same time here. So this is one Stream Analytics job that's outputting to 3 different places at the same time. One to blob storage, this is like the raw data. One to another event hub to trigger some of the downstream processing. And this is the one I want to focus on for now. This is an output to a SQL database. Here you can see we're from the event source, and then we're joining the blob source, which is the reference data that we just took a look at. Joining those on VIN, on the vehicle identification number. And then here's the windowing concept I had mentioned earlier. So every 3 seconds, we're running this query and calculating an average for every 3-second window. Various aggregates like count the number of cars of this model in this city, and average engine temperature, average speed, and so on. And these are being pushed into that SQL database every 3 seconds. Okay, so just actually even just the last thing I want to show you is actually I've got the SQL database right here pinned to the dashboard, so I just want to show you what that looks like. This is the database where that data is being pushed. So I'm going to open this up in the portal, this query editor. I'll just log in real quick. Oops, I didn't actually mean it. Here we go. Get that right. Okay, the tables, I know it's going to, it's going to this table here. So let me get this query saved. So this is so now I'm in the database that has been configured as an output from that Stream Analytics job. And I'm specifically just doing a simple query against the table where that data is being pushed to. This real-time vehicle health report. This is the results of the query that we just reviewed, and just a top 10 just to get a look at what those records look like. So it's nothing super exciting, but what you can see here is there's the model name. So this is one thing I'm going to just make totally clear. The model name is included. So this is a field that came from the reference data, the CSV. This did not come out of the stream. So this sort of proves that we successfully, in Stream Analytics, joined a static CSV to a stream of data from Event Hub, and this is the result of that. And then we're doing per model and city, the average number of cars every 3 seconds. So I guess there's only 1 in this case. Average engine temperature, speed, fuel, and so on. So this is right here in a database where you can query it. A visualization tool like Power BI could hit this and do whatever visualizations, and it's being updated in near real time. And that is essentially what I wanted to cover.
Hi Ryan, there are some questions in the window, and I think Jean is answering those. So if
cool.
John, thank you. Excellent session.
Yeah, okay, yeah. So I'm just checking out the window. Let's see.
And there was one in the beginning of the window that's like about Databricks and Stream Analytics. Seems like there is some overlap of functionality. So where do you see one versus the other? Or is there a correlation? So
Right, right. Yeah, there could be. So Azure Databricks, for those who haven't heard, is a newer service. It's in preview in Azure, and Azure. So there could be some overlap. It just sort of depends on your needs. You can actually do streaming and analytics in Azure Databricks using Spark streaming. So that will sort of the differences would be you'll have more options, a little more flexibility if you're writing Spark code to write the more custom kind of streaming code. On the other hand, you'll have to write more code. So you saw how simple it was to spin up and run, and even some of the complexity that you can get out of the Azure Stream Analytics tool. With Databricks, you might have more options, but at maybe the cost of a bit more customization required. So let's see, Sean might have covered everything else. Let's see here. I'm just going back through. Were there any that we've missed here?
Folks, if you have any questions, please, either open your unmute and speak, or type in the IM window.
Yeah, so can you tell me what's the issue with ASA on Edge? Like, how is it different?
Yeah, so it's really not. I mean, the difference would be that it's not running in the cloud. It actually is running in a Docker container on the Edge device. So that is really the main difference. It's managed in a way through Azure still. So you would still develop your Stream Analytics job in Azure, and then you would just deploy it via the Azure IoT Hub down to the device, and then it would just run on the device, even when you have no Azure connectivity. But you would need to reconnect to Azure in order to do like updates if you wanted to iterate your job or add some logic to it, for example.
So does the Docker know about, or does Azure know about that Docker image, where it's located and all that stuff?
Yes, and it's actually IoT Hub where that is managed. IoT was kind of the central point that is managing the Docker deployments.
Okay, so the Docker will be like as a resource in IoT Hub itself.
Yes, well, IoT Edge is like a I guess you call it a resource or primitive in IoT Hub. So within IoT Hub, you can use that to send Stream Analytics jobs down to IoT Edge. There are also other kinds of containers that you can send down to your IoT Edge. IoT Hub would be the place where you're managing those things.
Cool, thank you.
So yeah, Nivi, it looks like we're out of time. Okay, well, yeah, thanks everybody for joining, and I think you saw my contact info, and I think Naveed's going to be posting the recording, and please feel free to reach out. Hope this was valuable. Thank you.
Thank you.